All right, these problems are a little bit different. They give us 2 points, and these 2 points are 2 points on our quadratic, and they want us to find the general form. Again, a reminder, they're talking about this. So they're giving us HK, and that's the first thing we're going to substitute. We're going to substitute HK. So y equals a, x minus h plus k. Simplify. And the next thing we're going to do is substitute xy, because the thing that we don't know and that we're trying to get at is what's a. So we're going to do that second substitution, and then we can calculate a, and then we can finish writing our equation. All right, there goes x. I already put in y. Let's simplify. Okay, 2 squared is 4. And it looks like a squared is equal to 1. Sorry. Why am I dragging around the squaring? I should have dropped it when I squared the 2. I don't know why I'm doing that. All right, so equals 1. And our final, what they call standard form, is going to be y equals 1, x minus 0 squared minus 2. I'm going to clean that up a little. And that one's done. Kind of the same idea. So what I want you to do is go ahead and try this on your own. I'm going to stop the video, put up the answer, and then hopefully we'll be right on, and if not, maybe we'll figure out where either your error or mine is. All right, so there's my answer. Hopefully it agrees with yours. If it doesn't, you can't figure it out, let's talk. Okay, we get into a few application problems, and I noticed that I definitely needed a graphic calculator for these. So number 15 is it's just a height equation. You know, the equation they give us for height is pretty standard. It's just -16, that's the pull of gravity, times t squared, plus 96t. 96 is always, the number in front of t is always your initial velocity. And then you can also have it so that if you're throwing the object from a height above ground, that you could put that that initial height in as well. But because it's not there, we assume that they are throwing the object from ground level. And we're going to make the assumptions that that we're not going to think about how high the person is. We're just going to go ground to ground. So when this book gives us these problems, they are always really easy to factor. This one, if I set h equals 0, and I am, solving for h equals 0, I see that both 16 and t are common factors of both terms. I think t goes into 96 6 times. So I can rewrite this, and it's great that it's factorable because it makes the solutions really obvious. Oh, I factored out a negative, so my factoring will give me a negative where I see a positive in front of the velocity in the original equation. But if you look at this, you have 2 possible solutions. First solution is -16t is equal to 0. Well, that just means t is equal to 0. And that makes sense because it was at 0 time that they threw the object. And our second solution is t equals 6. So it's going to take 6 seconds for the object to return to the ground. All right, these next 2 are fairly in-depth, so I'm going to stop this video and then move on to the last one.